Hello everyone, how are you all? So today I am going to discuss a very important chapter, current electricity, and this chapter is not only important for your KCET exam but also for your board exam. This is the highest weighted chapter among all the chapters. This is not only important for KCET, this is also important for board. In both cases, both exams, KCET as well as board exam, this is the highest weightage chapter, right? So let me show you the weightage of this chapter. So if you see that from this chapter we are going to get total of 13 marks. Total 13 marks is allotted for this chapter, and we are going to get one marker question, one 2 marker question, no 3 marker question, but we are going to get 2 5 marker question from this chapter for PUC, right? So total marks that you are going to get in PUC, that is 13 marks. So 2 5 marker question means you are going to get one derivation pakka and also one numerical for sure. So total 13 marks you are going to get from this chapter. Okay, so if you watch today's lecture, those 13 marks will be guaranteed. What else? If you see the KCET year-wise analysis, you will see that in 2025 6 questions came from this chapter. In 24 6 question, 23 6 question, 22 7 questions came from this chapter, 21 slightly less 4 questions, and in 2020 again 6 question is coming. So we can expect another 6 questions in the year of 2026. So 6 question in KCET and 13 marks in your PU board exam. Hello Rashmi. Hello Anish. I don't see any problem with my audio device. My audio device over here is perfectly fine. You can check if your device audio is lowered. Okay, you can check your device audio. If you are watching it on a browser, check whether the audio volume of the browser is at max or not. Okay, because I can see the audio is at maximum. Okay, let me check once more. Fine, you can check if your device, yes, even in my mobile device also I can hear my voice clearly. So if you still have, sir, come to CTA. What is CTA? Stress. Okay, thank you. So if you see that you are going to get 6 questions in KCET, and you are also going to get 13 marks in your PUC exam as well. So this is one of the most important chapter of your PUC. Now we have done a PUC analysis of this chapter as well. So in this PUC analysis, if you see drift velocity, mobility, in 24-25 there was no question. In 23 we have 2 questions coming from this chapter. In 2022 again 1 question. In 2020 1 question. Okay, there was no exam in 2021 due to COVID time. So total 4 questions came from this concept: drift velocity, mobility, conductivity. Okay, the relationship between mobility and drift velocity, electric field, etc. Ohm's law and its limitation, this is the most common question. So Ohm's law and its limitation is the most common question from this chapter in PUC. Either you will get state and explain Ohm's law, or you are going to get 2 drawbacks of Ohm's law. Okay, 2 drawbacks of Ohm's law, because you are going to get only 2 marks this year. So 1 every year, 5 questions you are going to get. Shreyas, yes, I remember you, Shreyas. How are you? So you are completed your course last year, right? So yes, welcome to chat, Shreyas. How can I forget you after what you did with me, right, Shreyas? So current and current density based question will come only once. Resistance and resistivity, this is also one of the most important concept. This came 3 times including 2025. Cells in series and parallel, it came again 24, 25 and 22. In 25 there was a numerical question based on cells in series and parallel. Kirchhoff's law, another very important concept, Kirchhoff's law and Wheatstone Bridge. Now Wheatstone Bridge derivation is very, very important. Hi Rukmini, hi Suprita, how are you all? Right, so Kirchhoff's laws and Wheatstone Bridge is also very important. 4 times it came in last few years, right? Now, so we will start with electric current, the basics of electric current, and then we will move on with other concepts, okay? So the net amount of charge, small q, is flowing across the area in the forward direction in the time interval small t, then the current is. Now you might think this is very, very easy formula, very easy concept, but we will show you some question that came in KCET based on this concept, but very deep, okay? So current is basically given by charge per unit time. Current is given by charge per unit time. So if you know the charge, if you know the time, you can calculate charge per unit time. Currents are not always steady, and hence more generally we can define current as follows. So I is basically given by dq by dt. Now why this formula is very, very important, okay? So I equals to dq by dt. Sometimes they might give you a charge with time variance and they will ask you to calculate the current, so you have to differentiate the charge to calculate time. But in KCET there was an opposite question came where you have to calculate the charge where a graph is given. So if you are given a graph of current versus time, if you are given a graph of current versus time, okay, then the charge that is flowing is actually the area under the graph, okay? So charge can be written as integration I dt. Okay, what is integration? Integration is nothing but area under a graph, definite integration. Hi Akhil V. Opposite direction. What is opposite direction? Yes, generally the direction of current is in the opposite direction of flow of electrons. Yes, but generally charge means we assume positive charges, okay? Opposite direction of flow of electron, then we say this is the direction of current. And when we are talking about charge, we are talking about current, generally we assume positive charge, even though positive charge does not flow. But while discussing this chapter, we assume the current is basically flow of positive charge, conventional current, okay? That is the reverse direction. Lack of electron is positive, right? So electron is moving say from negative terminal to positive terminal, can be equally be said that a positive charge is moving from positive to negative. Okay, that's why conventional current, when before discovering electron, the concept of current was there. Okay, even without knowing what is charge, how the charge flows, current concept was there even much before than that, almost 50-60 years before electron was discovered. Current was still, we have discovered current and we were using current. So that's why the conventional direction of current is basically taken when assuming a positive charge is flowing. Okay, so charge can be calculated by integration or area under the graph. We will see one example problem based on this exact concept. Okay, now let's move on with electric currents in conductors. So basically in electric charge chapter, we have electric field chapter, we have discussed there are 2 types of materials, conductors and insulators. Through conductors, electron can move freely. So if electron can move freely, then they are called conductors. Okay, so electric charges experiences a force in the presence of external electric field. So suppose we have an external electric field, and if we have a charge, positive charge, assuming positive charge, so this charge will experience a force in the direction of the electric field. In case of negative charge, If the charge is negative, say electron, okay, the charge will experience a force in the opposite direction of the electric field. So if there is an electric field and we put a charge inside that electric field, it will experience a force. It can be in the direction of electric field, it can be in the opposite direction of electric field as well, based on the polarity of charge. If charge is positive, it experiences force in the direction of electric field. If it is negative, it experiences a force in the opposite direction of electric field. Electrons being negatively charged move opposite to the direction of the electric field. So as I mentioned, electrons are negatively charged, so they move in the opposite direction of the electric field. Metals having a large number of free electrons, metals or conductors in general have a large amount of electrons. We say sea of electrons. So electrons are basically like sea water, okay, they are moving like sea water inside a metal. So they can move inside a metal. I am electronics student, sir. Okay, very good. I also had electronics, but not in your PUC, but afterwards I also had electronics. So I also have basic idea what you are talking about. So metals having large number of free electrons. Now these electrons accelerate in the presence of external electric field. So if you apply external electric field around a metal, okay, then the electrons will move in the opposite direction of the electric field. Okay, this gives rise to the electric current. I hope whatever doubts you have, Akhil, is cleared. Austin is asking, hi sir, I got 75 of 80 maths, 50 in physics and 37 in chemistry with half syllabus completion. Can I get 290 in finals? Austin, 10, obviously you can get 290, but you have to work really hard. And pre-board was one of the area where you could have tested that how much you can get with the full syllabus preparation. So even if you have scored with half syllabus preparation, you can get 290 plus, but you have to work really hard and you should not play games, free fire with your friends anymore. Your time is now and you should focus more on study. For example, this chapter can give you a 13 marks more. Okay, so if you study this chapter completely, then 13 marks is in your pocket, right? So you have to be a little bit more proactive in your preparation, then you should go score more than 290. 290 is nothing, okay? And in physics also, your practicals, I am assuming you are scoring at least 28-29 marks. So in that case, 290 plus will not be a difficulty, right? But you have to, if you are making any mistakes or what, you should know that area where you are weak. For example, if you are not able to solve numerical questions, so you have to practice a little bit more of numerical questions, and the chapters that you have not studied, study those chapters, make yourself strong enough, then you can score 290 plus, right? So the current is basically when you apply an electric field around a conductor, okay, the electron move in the opposite direction of the electric field, and that is basically we are calling that as electric current. Okay, now how do we apply electric field? To apply electric field, we have to remember one formula that we have studied in our electric potential, that potential and electric field are related. Okay, potential and electric field are related. So electric field was nothing but rate of change of potential with distance. Okay, so electric field was nothing but dV dx. So potential has a relationship with electric field. So if you can apply a potential difference, so potential difference is very, very essential. Potential difference across a conductor, that will produce an electric field. And that is the basic of all electric current. Okay, so if you can apply a potential difference across a conductor, the conductor will produce electric field, right? Now, now here comes Ohm's law. Ohm's law is the most basic fundamental law of this chapter, and this talks about the relationship between current that is flowing in a conductor and potential. So it is very difficult for us to do integration and differentiation every time. So we need a more fundamental formula which relates potential and current directly, potential difference and current directly. And here whenever we see V, that represents potential difference. V represents potential difference directly. No delta V, no business of delta V, no business of dV. Okay, we will only talk about V. If the temperature and other physical conditions remains the same, okay, if temperature and other physical conditions remains the same, the current through a conductor is directly proportional to the applied potential difference, that is V is proportional to I, that is V is equals to R. Now let me explain these two terms, temperature and other physical conditions. So what is the meaning of temperature? Temperature is very obvious. If suppose you are performing an experiment at say 20 degrees Celsius, the entire experiment has to be done in 20 degrees Celsius only. If the temperature changes, then this law will no longer valid. In fact, Ohm's law has some limitations in terms of temperature that we will see in a while, but temperature has to be a constant. This is called a constant of Ohm's law. What is the other physical condition? Other physical condition means suppose you are sending current through a copper wire. Suddenly the temperature increases, the wire melts and it becomes a liquid. So in that case also the Ohm's law is not valid. So other physical condition means, so whatever condition of the wire is there, the same condition has to be maintained. It cannot extend in length, it cannot contract in length, it should not melt. So if those conditions are satisfied, then only this law is followed exactly. Otherwise, is the law valid? Yes, the law is still valid in many cases, but with some modification. Either you have to modify R or I or V, and the law is still valid. But exact form has, if you are getting the exact form, then these two conditions has to be valid. The constant of proportionality, capital R, is called the resistance, right? Resistance of the conductor. So this R is called resistance of the conductor. So as the name suggests, it depends on the conductor. It varies from conductor to conductor. The SI unit of resistance is ohm, and it's denoted by the symbol omega, capital omega. This is capital omega. The resistance R is not only dependent on the material of the conductor, it also depends on the dimensions of the conductor. It depends on the material of the conductor. It also depends on the dimension. Dimension means size, length, area, etc. I am a JEE aspirant, sir. I got 63 out of 17 physics, sir. Very good, Akhil. Hi sir, negative e to the power minus dv dx. Yes, negative sign I have ignored. I don't get. My lamp, hi my lamp. Alteration means I don't understand. So minus sign I have ignored. I have just taken the magnitude, okay, magnitude of electric field. So whenever we are not writing the negative sign, do not misunderstood me. I am talking about the magnitude, because in many cases magnitude is more important. Unless you are doing the experiment inside the lab, then the sign is important. Otherwise, in case of a normal discussion, magnitude is sufficient, right? Now there is one more form of Ohm's law, that is J equals to sigma E, and sometimes they will ask, starting from Ohm's law, prove J equals to sigma E. That is one 3-marker derivation, but 3-marker derivation is no longer part of your question pattern, because question pattern is changed. Only 2-marker question will come and a 5-marker derivation. So if 2-marker question comes, most likely it will be Ohm's law or its drawback. Okay, so this derivation is not that important right now. Okay, so J is equal to sigma E. The form you have to remember, because based on this you might get an objective question. Okay, now resistance and resistivity. So I was talking about the resistance does not depend only on material, it also depend on dimension. So resistance equals to rho into L by A. So this rho is called resistivity, sometimes also called specific resistance, not specific resistivity, specific resistance of the conductor. Okay, so rho is called specific resistance or resistivity of the conductor. So when I was a student, during our final board exam, instead of asking resistivity, they asked specific resistance. Many students was confused. What is specific resistance? The term was completely new to many of them. So specific resistance is nothing but resistivity. You should remember that. Specific resistance is nothing but resistivity. Resistivity is independent of the geometry of the material. That means resistivity does not depend on dimension. It does not depend on length or breadth or area. Okay, it varies from material to material and on the temperature. So for example, resistivity of iron is different than that of the copper, and also it depends on temperature. As the temperature increases, resistivity increases. So this is the linear proportionality. Okay, so rho T is the resistivity at temperature T, rho naught is resistivity at temperature 0 degrees Celsius. Okay, we generally take the temperatures in Celsius, not in Kelvin. Alpha is called the coefficient of resistivity, temperature coefficient of resistivity. Okay, alpha is the temperature coefficient of resistance. So how resistivity or resistance changes with temperature, this is the formula. Now remember, because resistance and resistivity are directly proportional, so resistance can also be written as RT equals to R naught 1 plus alpha delta T. This is the formula that you should remember. Delta T is the difference in temperature. Okay, so resistance also depends on temperature. Resistivity is only depends on temperature and material. Okay, if material is fixed, it only depends on temperature. Resistance depends on length, depends on area, it depends on the temperature as well. Note, resistivity of metals increases with temperature. Okay, so resistivity increases with temperature, that means resistance also increases. Resistivity decreases for semiconductors. For semiconductors, very important, for semiconductors, resistivity decreases with temperature. Okay, so for conductors, normal conductors, resistivity increases, and it is increases non-linearly. Graph is non-linear. Okay, resistivity decreases with temperature for semiconductor, so it decreases with temperature for semiconductor. This is conductor, this is semiconductor, and for few alloys such as nichrome, constantine, manganese, whose resistivity change is very small with increase in temperature. Its resistance changes very small, so it almost a straight line. This is for alloy. Some alloy, not all alloys, but nichrome, then manganese, constantine, these materials, their resistance changes very, very slowly. Okay, let's see one question. This is a KCET PYQ from the year 2024. The electric current flowing through a given conductor varies with the time as shown in the graph below. It is not below, it is on the left hand side. The number of free electrons which flow through a given cross section of the conductor in the time interval 0 less than equals to t less than equals to 20 is. Okay, so you have to calculate the number of free electrons. So they have given you a graph, and from this graph you have to calculate a number of free electrons. What question it is? Completely bamboozling question, right? Completely difficult question. Actually it is not. Yes. Sir, why resistivity depends on temperature? So Mansa, what happens is that the atoms present inside a conductor, okay, metals generally, they have electrons which is orbiting the nucleus. Now if you increase the temperature, from the thermodynamics we know that the vibration of the atoms increases, right? Degrees of freedom you have studied. It is a little complex than normal thermodynamics that you have studied. It called solid state physics, but we can understand, okay, that temperature is given by the vibration of the atoms, right? Higher the vibration, higher is the temperature. That much we all know. So what happens when you increase the temperature? The atoms start vibrating much more. Okay, and the electrons which are present inside the atom, they are also vibrating along with the atom. So atom is vibrating, electron is vibrating. Now electrons, when they are vibrating more, they tend to collide more with other electrons. Okay, so when the electrons are colliding with each other, it is very difficult for any electron to pass through the conductor without any collision. So more collision means the electron moves slowly. Imagine you are driving a car in a road. Okay, the road is completely clear. There are no other car, you can easily move through the road without any difficulty. Now you imagine the same road, now many cars have collided, there is a very huge traffic jam happened. Okay, so all the electrons have collided and they are almost stranded. Okay, so the electron which is trying to move through that traffic jam, it will be stuck behind all those traffics, right? So basically you can say that because of those vibration, more number of collision happens, and more number of collision means it is very difficult for an electron to move freely from one point to another point. Okay, and the electron starts moving slowly, and because of that the resistance increases, the resistivity increases. Now this property is property of the material. Some material even at high temperature can carry a large amount of current because their collision is still smaller compared to some other material. Okay, so they have a some material have higher temperature coefficient, so they tend to increase their resistance more. Some material have very smaller temperature coefficient, their resistance does not change too much. Okay, so based on the material, the resistance change can be very sudden and it can be very quick as well. Right, Mansa, I hope your doubt is clear. It is basically the vibration of the electrons. More vibration means slower motion and more resistance. Resistance is the measure of how material tries to stop an electron. Okay, so suppose you are trying to swim in a water, the water will try to stop you. So that is the resistance of the water. Similarly, resistance of a material basically indicates that electrons are not allowed to pass freely, they are being stopped by the other electrons present in that metal itself. Okay, so more vibration means more collision means slow motion means more resistance. Okay, now answer this question. The electric current flowing through a given conductor varies with time as shown in the graph below. This is the graph. Okay, the number of free electrons which is flowing through a given cross section of the conductor in the time interval t equals to 0 to 20. So we have to start at 0, and we have to move till 20. Okay, and during this duration we have to find not the charge but electron. Okay, so how to do that? So I have already explained that this is a current I versus time graph. So if you can somehow calculate the area under this graph, you will be able to calculate the charge. You will be able to calculate the charge that is being carried away. So if you can calculate the charge, remaining part is easy. You need to use the formula N into E and calculate the electrons, number of electrons, N. So N you have to calculate. First you have to calculate the area, and the area will give you the charge. Okay, so how to calculate the area? So if you can divide this into two portions. One is this trapezium and one is this rectangle. Okay, so this trapezium, how to calculate the area of a trapezium? Now again you can further divide it into a triangle and a rectangle, but that will be a waste of time. You can directly calculate the area of a trapezium. How to calculate that? So area of a trapezium is basically the half into sum of parallel side, remember this, parallel sides into the distance between the sides, if you forget it. Okay, so what is the sum of the parallel side? Parallel side means this plus this. Okay, so if you see the graph properly, okay, if you see this graph properly, so this is the parallel side. Just hold on a minute, my cursor is stuck. So if you see this portion, this is basically this much is 200, this is 0, so this height is exactly middle between 0 and 200, so this must be 100. Similarly, this is 200, this is 400, this is the middle, so this must be 300. So this graph is also, you have to interpret what are the values. Okay, so this is not super simple and easy graph. Okay, so now so if you see the sum of all the sides into the distance between the side, that means sum of the side means 100 plus 300, so half into 100 plus this much is 300. Okay, sum of the parallel sides into the distance between them. Distance between them means 0 to 10, that is distance will be 10, right? So here you can calculate the exact area of this portion. This is the trapezium portion. What about the rectangle? Rectangle is simple. Rectangle is length into breadth. Now what is length? Length is 300. So plus 300 into breadth is 20 minus 10, that is another 10. Okay, now simplify this. So 100 plus 300 is 400. 400 into 5 plus 3000. So this will be 5000. So this is the total area. Now here the unit is also very important. This is milliampere. The current is given in milliampere, so that means this will be millicoulomb. Okay, so total charge that is flowing is 5000 millicoulomb. That is 5 coulomb. So total charge we have calculated is 5 coulomb. Now I told you one shortcut formula to directly calculate the number of electrons. So the number of electrons will be given by 6.25 into the charge into 10 to the power of 18. Okay, 6.25 into 10 to the power of 18 is the number of charge for 1 coulomb. For 5 coulomb it will be multiplied by the charge. Okay, so it will be 31.25, right? 31.25 into 10 to the power of 18. This is the number of electrons. Okay, so if you see, only one answer is possible, 3.125 into 10 to the power of 19. Okay, so 5 6 are 30 and 5 into 0.25 is 1.25. That's how I have calculated 31.25. Right? If you have any doubts, you can mention in the chat. Now next question. This question is directly whatever I have taught in the lecture. The variations of resistivity rho with absolute temperature capital T for 3 different materials X, Y and Z are shown in the graph below. Identify the 3 materials X, Y and Z. Okay, so one of them is conductor, one of them is semiconductor, another one is alloy. Okay, so here semiconductor, nichrome and copper are given, so you have to identify correctly which one is copper, which one is nichrome, which one is semiconductor, right? Please answer it quickly. Let me have some sip of water. Okay, so what is the answer for this question? What is the answer? So this one, resistance or resistivity decreases. So resistivity decreases means this must be semiconductor. This must be semiconductor. Okay, for this one resistivity increases with temperature. This is temperature. So for this one resistivity increases with temperature, that means this must be copper. And for this it is almost constant. Don't fool by it is increasing with the straight line. The variation, the graph scale is large, so that's why it is giving you this change. But if you zoom in into the graph scale, then this will be exactly almost constant, so this must be nichrome. Okay, so now you figure out the correct answer. X is copper, Y is nichrome, Z is semiconductor. So definitely option C is correct. X is copper, Y is nichrome, and Z is semiconductor. Okay, now few questions for your PUC. Constant N wire is used for making standard resistance because it has high melting point, high specific resistance, low specific resistance, negligible temperature coefficient of resistance. What is the answer? Yes, G sod, C was correct. Now answer this one. Constant N wire is used for making standard resistance because it has high melting point, high specific resistance, low specific resistance, or negligible temperature coefficient of resistance. Specific resistance is nothing but resistivity. I already mentioned, don't be fooled by this term, it is nothing but resistivity. Specific resistance is same as resistivity. Rashmi is saying option D, yes, negligible temperature coefficient of resistance, constant in then nichrome, they are the substances which have very, manganese is also one of them, they have very low temperature coefficient, they have almost constant temperature coefficient, so their resistance does not increase by much. So standard resistance means we want to have them, your resistance boxes, if the resistance that you are using in your lab experiment, the resistance boxes or the coil resistance that you are using, okay, rheostat, so those are basically using this kind of materials. And the main reason is that if you are using some resistance, their resistance changes with temperature, then it will give you a wrong value. Okay, if you perform the experiment in summer or if you perform the experiment in winter, you will get different values. That is not desirable. So we generally use constant in or manganese or nichrome, right? Next, in the equation AB equals to C, AB is the current density, C is the electric field. Then what is B? Resistivity, conductivity, resistance, potential difference. Very simple. In the equation AB equals to C, A is the current density, C is the electric field, then B is, what is the value of B? So AB equals to C. So this equation is very common to that of J equals to sigma E. Okay, in vector notation, if J and E are in the same direction, in that case we or basically they are in the same direction, so we can ignore the vector sign for now and we can just write the scalar form. So in that case, what is the value of B? So here A is current density. So current density AB equals to C. The equation is given AB equals to C. So A is current density, B is unknown, C is electric field. So if you compare these two equations, okay, you will see that B equals to 1 by sigma or 1 by conductivity. So that means G sod is answering B. Okay, let me see. So B is equals to 1 by sigma. Okay, so it is 1 upon conductivity. 1 upon conductivity is nothing but resistivity. So resistivity and conductivity are step brothers. They are inverse of each other. Okay, so if one is high, another one will be low. If one is low, another one will be high. Okay, like that. So a good conductor has a very low resistivity, a bad conductor has very high resistivity, right? Similarly, a good conductor will have a very high conductivity, a bad conductor will have a very low conductivity. Okay, so that means if you compare these two equations, you will get that B is nothing but resistivity. B is nothing but resistivity. So not option B, but option A is correct, right, G Sword? So correct answer is resistivity, not conductivity. Okay, so this is very tempting problem. Okay, easy question. Okay, and one such question came in KCET few years back as well. But this question is simple if you compare, if you write down the values. Okay, so the A is mentioned current density, C is mentioned electric field, but we know the formula J is equal to sigma E. So if you write it down, you will get E equals to J upon sigma, right? So from there you can say that, okay, from comparing we can say B must be equals to 1 upon sigma, so it cannot be conductivity, it must be resistivity, right? Now, drift velocity and mobility. So what is drift velocity? So drift velocity is basically when you apply an electric field in around a conductor, the electrons starts to move in the opposite direction very slowly. Okay, that is called drifting. Okay, for example, some of you may have visited sea, right? Seashore, or maybe traveled in a river. Okay, so when you visit a sea, if you just put a ball inside the waves, okay, so what happens, that ball slowly start moving along with the wave. Okay, it only move along with the wave. Whatever is the speed of the wave, the ball moves along with it, right? So that motion is called drifting. So based on the motion of the wave, whatever the speed of the ball is, that is called drifting. Whereas if you see a boat in the river or in the sea, okay, so in the ocean, Indian Ocean or maybe Arabian Ocean, there are two oceans on the two sides of India, so you may have visited one of them. And if you see a boat in the ocean, okay, so if the boat is moving, it moves with a motor, or using in the ancient times it was using rowing. Okay, so we used to row the boat to move it, right? Now, so that is not drifting, that is acceleration, that is a motion where some force is involved. Okay, if there is no such force is involved, then it is called drifting. Okay, and this drifting in case of electron is basically happens because of the electric field. So even though electrons should accelerate, but they actually do not accelerate, they move with a constant speed, and that speed is called drifting. It accounts for the internal resistance of the conductor as well as the electric field that is being applied. Okay, and it's very important to know that the drift speed is given by minus E by m into tau. The negative sign represents the electron moves in the opposite direction of electric field. That's it. Okay, electron moves in the opposite direction of electric field. That's why there is a negative sign. Okay, tau is called the relaxation time. Tau is called relaxation time. What is relaxation time? So you have appeared in one exam, now you are going to appear one more exam in future. So between these two exams, you are just relaxing. Okay, we were saying that, okay, I will prepare for the next exam in a day or two. So let me relax a day for a day. Okay, so basically electrons, for electrons the exam is the collision. Okay, so when electrons collide with each other, okay, and they do not have anything else to do, so they just collide with each other. So first they collide with this, and then they move and collide with the second one. So when they are not in collision mode, when they are not colliding with each other, the time gap between two collision is called relaxation time. So electrons are also like you. Okay, they also study just before the exam, right? So they relax in between exam, right? So they only collide with each other, and the time gap between the two collision is called relaxation time, tau. Now current in a conductor in terms of drift velocity can be given as I is equal to NEA VD. This is very important formula to remember. I equals to NEA VD. What is N? N is the number density of electron, okay, which is generally constant. Number density of electrons, E is charge of an electron, A is area of cross section of the conductor, and Vd is the drift velocity. Okay, now if current in a conductor is constant, N is constant, E is always a constant, universal constant. N is for a given conductor, N is also constant. Number density means number of electrons per unit volume, which is also constant. So that means area into Vd is also constant. So if current is constant, then area into Vd must be constant. Now if you have a wire, okay, of non-uniform cross-sectional area, if you have a wire of non-uniform cross-sectional area, but the current that is passing through this is constant, then basically the drift velocity is inversely proportional to the area. More the area, low is the drift speed. Okay, so if in this case, as you can see, area is more, so drift speed say is VA, and in this case drift speed say VB. So VA is less than VB. Okay, more the area, less is drift speed, less the area, more is drift speed. So less the area, drift speed is more. Here area is more, so drift speed will be low. This equation is called equation of continuity. This equation is called equation of continuity. Now current density, what is current density? Current density is current divided by area. So this is given by NEVD. NEVD. Okay, and from there we can say if you put the value of drift speed, you will get NE square m E into tau. Okay, and we know that this is again equals to sigma E. So if you compare this, you can also calculate the conductivity. So conductivity is given by NE square tau upon m. Okay, so the derivation is also very important. This derivation might come, so you have to remember the equation of drift speed. You have to remember these two equations completely, and also Ohm's law. From Ohm's law, J is equal to sigma E. That small derivation you have to do, and then you just need to put this. Okay, so then you can get full marks. In between, there is one more quantity which is called mobility. Mobility is a measurement of how an electron can move freely inside a conductor. Okay, mobile. Okay, mobile means how easily it can move. Higher the mobility generally, okay, the electron can move more at higher speed. Okay, higher mobility means electron move with higher speed. Okay, so drift velocity divided by electric field is called mobility. Drift speed per unit electric field. Drift speed per unit electric field is called mobility of the conductor, and as you can see, all the quantities are actually directly proportional to relaxation time, right? If you have any doubt, don't forget to mention in the comment section below. Now limitations of Ohm's law. So we have studied Ohm's law. Now let's see a few limitations of Ohm's law. So first of all, V ceases to be proportional to I. So we know that V is proportional to I, that is the Ohm's law, but in a particular case, V is no longer proportional to I, and that happens at very high temperature. Very high temperature. So at a very high temperature, Ohm's law is not valid, because at very high temperature, V is no longer proportional to I anymore, and it is not a straight line graph anymore. The graph deviates from the straight line path, and it slowly becomes a curve. Okay, Ohm's law, normal V versus I, direct proportionality. Direct proportionality means we are expecting a straight line graph passing through the origin. But if V is no longer proportional to I at higher temperature, in that case the graph deviates from the straight line path, and Ohm's law is no longer valid. Next, the relationship between V and I dependent on the sign of the voltage. Okay, so this is temperature is high, At high temperature, V is no longer proportional to I. Now, if you increase the current, okay, if you give a positive or negative voltage, based on the positive and negative voltage, the current behaves differently. So this is a direct example of semiconductor where Ohm's law is not valid. Okay, so this is the IV characteristics of a semiconductor diode. This is the forward bias, this is the reverse bias. Okay, and if you see the forward bias graph is on milliampere, in the reverse bias graph it is microampere. Okay, so based on the nature of the voltage, so for positive voltage it is milliampere, for negative voltage it is microampere, so that again it is not a Ohm's law graph. Okay, so Ohm's law is no longer valid. So if Ohm's law was valid, we will get a straight line graph like this, but we are not getting that, so that means Ohm's law is no longer valid. The last but not the least, the relationship between V and I is not unique. That is, there is more than one value of V for the same current I. Now, if you observe this graph up to this point, you might feel that this is a Ohm's law graph, because it is almost a straight line graph passing through the origin. So if you see the graph up to this point, you might feel, okay, the Ohm's law is valid. Even if you observe only up to this point also, you might feel the Ohm's law is still valid. Okay, so graph, if the graph is shown to you, you will say, okay, this is a straight line graph, Ohm's law is valid. But if you increase the voltage further, you will see that after some time it is no longer a straight line, first of all. Second time when it is decreasing. So for same current you are getting two different voltages. That is not possible. V proportional to I means for one voltage you are getting one current. But in this particular example, you are getting two voltages for same current, which is again not allowed by Ohm's law. Okay, so this is also violation of Ohm's law. So Ohm's law is at higher temperature, Ohm's law is not applicable. Ohm's law is not applicable for devices such as semiconductors. So these are the drawbacks or limitations. Okay. Now let's see one KCET previous year question. Given a current carrying wire of non-uniform cross section, which of the following is constant throughout the length of the wire? Current and drift speed, current only, current, electric field, and drift speed. Okay, so given a current carrying wire of non-uniform cross section, so as I mentioned, non-uniform cross section. Okay, which of the following is constant throughout the length of the wire? Okay, so which is constant? Current and drift speed, current only, current, electric field, and drift speed, or only drift speed? Answer this question. Even at low temperature also, yes, Rashmi, at low temperature also again V is no longer proportional. In fact, the property of material changes at low temperature. So Ohm's law you will not be able to apply. Okay, so at low temperature some conductors behave like superconductors. That conductivity actually changes drastically. So low temperature physics basically is a physics branch of physics where we study only behavior of materials at low temperature, which is very tricky. You can mention at a very high and very low temperature Ohm's law is not valid, obviously. Okay, so both cases are correct. Yes, at very high temperature and at very low temperature, V is no longer proportional to I. So that's why Ohm's law is not valid. Yes. Answer this. A sword is saying option C. Let's see. Current, electric field, and drift velocity. So remember that this is a non-uniform conductor. So if the conductor is not uniform, only one thing and one thing is constant, that is current. Current is constant. Drift velocity is high over here. So drift velocity is high, drift velocity is low. Okay, drift velocity varies with area. Okay, so if the cross section of the conductor is not uniform, only current will be constant. Okay, only current will be constant. Electric field will also change, because how electric field depends on cross section, area of cross section, that can also be determined. So even electric field is not constant. So only thing that is constant is current only. So only current is constant, not drift speed is definitely not constant. Okay, so drift speed is mentioned over here, that means these three options cannot be correct. Okay, so only current is constant, not drift speed. Yes, Kavya is answered, has answered correctly. Mohammad Ibrahim, again as I mentioned, drift speed is not at all constant. Drift speed depends on area. So if the area is not uniform, then drift speed cannot be constant. If you see the question, it is mentioned non-uniform. If the question is asked uniform, if they ask uniform cross section, then option C is correct. Okay, but in the question they have mentioned non. So this non is very, very important to look for. Okay, so if the same question comes in your board exam, they might give you uniform cross section. So for uniform cross section, everything is constant, but in non-uniform, only current is constant, not drift speed. Another question: a charged particle is moving in an electric field of 3 into 10 to the power of minus 10 volt per meter with mobility 2.5 into 10 to the power of 6 meter square per volt second. Its drift velocity is. So mobility is given, electric field is given. They asked you to calculate the very difficult quantity, which is drift velocity. Okay. So if you know, this is a very easy problem. If you don't know, this is a very, very difficult problem. So what is mobility? So mobility is the mobile phone that you are using, right? What is mobility? Mobility is drift velocity per unit electric field. Now if you read the question again, electric field is given, mobility is given, you are trying to find drift velocity or drift speed. So drift speed, sometimes we call it velocity, sometimes we call it speed. Okay, because it's mostly drift speed is more accurate, but because it is related to electric field, we say drift velocity as well. So electric field is given 3 into 10 to the power of minus 10, and mobility is given here 2.5 into 10 to the power of 6. Everything is in SI unit, so no need to convert units. Okay, everything is SI unit, so no need to convert any unit. 2.5 into 10 to the power of 6. Okay, so the drift speed will be meter per second. So drift speed is same as the speed, so unit should be same. Now if you multiply 7.5 into 10 to the power of minus 4 meter per second. Okay, so if you see the answer, 7.5 into 10 to the power of minus 4 meter per second. So option B is correct. Yes, everyone answered. I think Kabia and Mohammad Ibrahim, Gsod, everyone answered it correctly. 7.5 into 10 to the power of minus 4. Now if you want to practice more such questions for preparing for your KCET exam, then definitely we have our own ABHYAS KCET test series, where you are going to get 35 KCET tests. You are also going to get 4 free if you want to try it right now, and 31 tests are paid, right? So you have to register yourself to get this free test series, and the link of our ABHYAS test series is given in the description section of this video, or any other video you can check in our channel. You'll get the link to join ABHYAS KCET test series, right? And what else? This year we are giving you free of cost KCET 10 years PYQs. So KCET 10 years PYQs in the form of quiz. So you can attempt and check how many questions from previous years you are able to solve. If the same question comes this year, how many of them you will be able to solve in time. So time management as well as KCET previous year question paper, everything you will get, and along with physics, chemistry and biology if you want, all 4 subjects are covered. And you can see these are the toppers from our last year's ABHYAS batch, and they did really well. Prajwal got 171, Kiran got 443, Deeksha got 693, Sachin got 934, and Mohammad Sahil got 2427. Right? Now let's move on. Drift velocity of electrons is due to A. Motion of conduction electrons due to random collision. Motion of conduction electrons due to electric field E. Repulsion to the conduction electrons due to inner electrons of ions. Collision of conduction electrons with each other. This is a PUC question, a lot easier than previous question. What is the reason? What is the cause of drift velocity? A, B, C or D? When will this happen, sir? What? Mohammad Ibrahim, ABHYAS KCET test series is already available. You have to visit the website. If you go to any of the video of our channel, in the description of the video you will get the link to join ABHYAS test series. Okay, this is a paid test series. Okay, the price is not high, it's not 14,000, 15,000, it is only 1,499. It is currently happening. You can purchase it today and you can use it till your KCET exam. So up to your KCET exam this course is valid. Okay, now Ibrahim is saying option C, repulsion of electrons due to inner electrons of ions. Okay, so drift velocity of electrons do not drift because of random collision or the electric field due to inner ions. Electrons drift only in the presence of electric field E. Okay, so if you apply an electric field, then only electrons starts to drift. Okay, so motion of conduction electrons. So if those who have studied semiconductor chapter, they are aware that there are different bands: conduction band, valence band. Those who have studied chemistry, they know valence shell. Okay, outer shell of valence shell is called conduction cell, and all those shell of a metal, when you are considering the bulk properties, the conduction shell, they all merge together and gives conduction band, which is very essential in physics. Okay, so when an electron is in conduction band, they tend to move in the presence of external electric field, and that is the reason behind the drift speed. Okay, so electrons basically in conduction band, they move in the opposite direction of the electric field. Okay, here the direction is not mentioned, but they have only mentioned the motion of the electrons. It can be in the direction, it can be in the opposite direction. So here it is the motion of electrons in the opposite direction of the electric field, and that is the correct answer for this question. Next, Ohm's law is valid when the temperature of the conductor is very low, very high, constant, varying. Very easy question. For which condition Ohm's law is valid? Kavya, again option B is correct, not C. Okay, so repulsion of electron part is correct. Okay, but it is not due to inner electrons. It is not due to inner electrons. It is due to external electric field. Okay, only because repulsion is mentioned, don't fall for the trap. Here neither repulsion nor attraction is mentioned. That means it's a general statement. It can be repulsion, it can be attraction as well, but electrons move in the opposite direction, so this is a repulsion only. But repulsion is not due to inner electrons, it is due to the external electric field. Okay. Yes, Prashant, Mohammad Ibrahim, you are correct. It is option C, which is constant. Okay, Ohm's law is valid when temperature is constant. This is one of the constant of Ohm's law. Other constant, as I mentioned, is physical condition. Physical condition in a sense where the physical state of the conductor should remain same, the length should remain same, the width should remain same. So those are the physical condition. Okay, now next part, combination of resistance. Now in KCET, resistance based questions and Ohm's law based questions are more prominent. Okay, and obviously again Wheatstone Bridge based Kirchhoff's law based questions. Okay, so combination of resistance. So we know there are two combination of resistance. One is series, obviously when one resistance is connected after another. Okay, this is called series combination. In series combination, current is constant. Same current flows through all the conductors, all the resistances. Okay, when the few resistances are connected in series, the current is constant, and the equivalent resistance is simple. We all know R1 plus R2 plus R3 plus dot dot dot. In parallel combination is when one is connected along with another, same starting point and same ending point. If starting point and ending point are same, they are called parallel combination, and in parallel combination the voltage remains same. The voltage across all three resistors remains same, not three, even more. Okay, so voltage remains same, current will be different. So current will be different in parallel combination and voltage will be same in parallel combination. In series combination, the voltage will be different. The voltage will be different, but current will be same. So these are the basic fundamental of series and parallel. Formula I know everyone knows, okay, but the fundamental concept many students don't understand, that in parallel combination voltage is constant, current different. In series combination current is same, voltage is different. Okay, for two resistances, R equivalent can directly be written as R12 divided by R1 plus R2. Okay, so this is the formula for two resistances. So now remember, if parallel combination based questions are asked, you have to take the reciprocal. If there are more than two resistances, you have to take the reciprocal. Do not leave your answer at 1 by Req and write it as R1 Req. So if you get say R equivalent is equal to say 5, for example, then R equivalent will be 1 by 5. Okay, so don't fall for the trap, especially for numerical MCQ based question. They will give you option 5 as well as 1 by 5. Okay, if you solve this, many times we forget that when we write R equivalent at the beginning, 1 by R equivalent is equal to, then equals to, and then at the end we forget that this is not the equivalent resistance, this is R equivalent. Okay, 1 by R equivalent. So you need to take the reciprocal of that to get the correct answer. So don't make that mistake. Clear? Okay. Now electrical energy and power. Electrical energy, so whenever you are using current in a circuit, okay, they basically consume something which is called power. If you are using a fridge or AC or any electrical gadget, okay, you will see that there is something called power consumption. Okay, and based on the power it consumes, you pay an electricity bill to the government, okay, the electric commission. Okay, so basically it depends on resistance, current and voltage, everything. So electric energy that you consume is given by VIT, that is vitamin. So if you eat vitamin, you will get energy. Okay, so similarly, when you are spending energy, you are spending vitamin, VIT, V into I into T. This way you can remember, okay, energy equals to vitamin, vitamin equals to energy. So energy consumed in a circuit is given by V into I into T. Okay, now power that is how strong is the device, how much power it can consume. Now power basically is the rate of energy consumption. Rate of energy consumption means how much energy it will consume in each second. Okay, so it is given by H divided by T. Power is how much energy it is consuming each second. Okay, so H divided by T is the power. So some device which consume say energy but power is small. Okay, some device which is consuming the same energy, power can be high because it is consuming the same energy in a small amount of time. Okay, now power is more accurate to determine whether a device is power efficient or not, energy efficient or not. So if the power consumption is low, then we say this is a very efficient device. Okay, based on that our standards regulators, they assign stars to different devices. Okay, if you are buying a 3-star fridge or 5-star TV, okay, 5-star means it consumes less power, 3-star means it consumes slightly more amount of power, 1-star means it is one of the worst type of device. Okay, no star means obviously it is outside, it is the highest power consumption, so it does not fall in the purview of the regulators. Okay, so regulators, they are saying to the regulator, we are not part of your regulation because we consume more power than whatever is required by you. Okay, so check. So if you have a fridge in your home, you should check the power rating and the star that it has. Okay, generally normal double door refrigerators, they are starting with 3 stars. Okay, if it's a single door refrigerator, they have 5 stars. Okay, so that means single door refrigerators are more power efficient compared to a double door refrigerators, right? Now, so power consumed can be given by 2-3 different forms. One of the common form is VI, power equals to VI. I used to tell my students that power equals to Vodafone Idea. Power equals to Vodafone Idea, VI. Okay. Or if you replace V with I square R, then you will I into R, you will get I square R. I square R is also power. Similarly, energy can also be written as I square R into T. Okay, and power is also V square by R, or here V square by R into T. These are the common formula for power and energy. If you have studied in your lower classes joules heating, then you are aware of these formulas. If you are not, then you should remember this very easy concept, not super difficult, and based on this concept also we might face some questions. Now, power rating of a bulb, which is very important, can be tricky. So power rating of a bulb, generally we used to have incandescent bulb, old generation bulb, where there was so it was you have seen the images, it was like this. Okay, okay, inside there was something called a filament. Okay, nowadays these kind of lamps are almost obsolete. Okay, some people try to recreate it using LEDs. Okay, but they are not the old generation incandescent bulb. When I was a child, this kind of lamp was more common, and they used to break even once in every 2-3 months, so you have to replace it. Okay, and these incandescent bulbs used to have this filament inside them. Nowadays we all use LED bulbs. Even LED bulbs also have a power rating. Okay, so this incandescent bulb used to come in the powers of 100 watt, 200 watt, 500 watt, right? Now LED lamps, even though they are much brighter, they consume less power. So it starts with 5 watt, 6 watt, 9 watt, 15 watt. Even a 40 watt LED bulb is huge, very highly bright. Okay, generally the light that we use, the tube light that we use in our home are 30 to 40 watts. The LED bulbs that we use are generally 9 to 15 watts. Okay, so that is how the power rating works. Okay, they also have power rating, not 100 to 100, but 15, 20, 40, up to 40 watt is sufficient. Okay, so you know that resistance of a bulb is given by, if power rating is given, say power rating is given, say 60 watt, 180 volt. Okay, that means when you connect this bulb with 180 volt power supply, it will consume 60 watt power. Okay, if the voltage is lower than this, if the voltage is lower than 180, it will not be able to consume 60 watt power, it will consume less power. If the voltage is more than 180 volts, say 220 volt, then this will burn more brighter and it will burn away. Okay, so this is true for incandescent bulb. For LED bulb also it is true that the bulb will glow brightly for few seconds and then it will burn. Okay, the circuit will stop functioning. Okay, so whatever is the power rating, generally the power rating has a range, so 180 to 220. Okay, modern bulbs have this kind of range, so 180, even the voltage fluctuates a little bit, it will still function with 60 watt power. But that means it will also have a resistance. Okay, the resistance can be analog resistance, it can be a resistance installed by the manufacturer. For example, this incandescent bulb has nothing, they only have this wire. Okay, and the resistance of the bulb is the resistance of this coil only. Nowadays LED bulbs have come with the circuit and that circuit has a resistance. Anil, here are the step-by-step solution to the most frequent numerical types in AC circuits. Mastering these patterns will help you almost any calculation in this chapter 1. I don't understand, Anil Revande, what you are saying. So all alternating current, we are not discussing alternating circuits, we are discussing current electricity. Okay, alternating current we will do in a later part. And alternating current, if you want to solve questions from alternating current, I have already done Brahmastra on alternating current, where I have explained step-by-step process on how to solve any AC circuit based questions. You can go and check that out, where I have solved more than 5 questions. All the questions are example problems and they are very important in your PUC exam, so you can do check that out for all alternating current related concepts. Here we are only discussing about normal current electricity. Okay, and alternating current, I don't believe that mastering alternating current will help you in this chapter, but if you master this chapter, this concept will help you in solving questions in alternating current, right? Now current is given by P by V. So if you want to calculate the current, maximum current which is allowed in a bulb, you can calculate using I equals to P by V. Again, power rating of the bulb you can calculate using V square by P. Now let's solve one question. 3 bulbs, 40 watt, 60 watt and 100 watt are arranged in series with a 220 volt source. The maximum light is obtained from 40 watt, 60 watt, all give the same light, or 100 watt. So basically the question is, here we have 3 bulbs, and they are connected in series with a 220 volt source. One is 40, another one is 60 and another one is 100. Okay, now if this is the configuration, which bulb will glow the brightest? Okay, so which one will basically consume the maximum amount of power? Now if this question is asked that they are connected in parallel, okay, our household circuits, they work in the principle of parallel combination. So in parallel combination, straightforward answer would have been 100 watt. But because they are connected in series combination, okay, the situation is slightly different. Okay, situation is slightly different because the current in this case is constant, not the voltage. So current would remain constant, not the voltage, and that's why the answer will be slightly tricky. So who can answer this question? Which bulb will glow the brightest? Which bulb will glow the brightest? 40 watt, 60 watt, 100 watt. Now you don't need to do any mathematics over here. Mathematics is not required. Only concept is sufficient to answer this question. Concept is sufficient to answer this question. Okay? The concept that we are going to use is that power is basically given by V into I, or V square by R. So from here we can say resistance is V square by P. Now if the power rating is given for a bulb, that means the voltage should be constant. Okay, power rating given at that constant voltage, single voltage. So resistance is inversely proportional to power. So higher the power, smaller is the resistance, and smaller the power, higher is the resistance. So 40 watt will have higher resistance compared to 100 watt. Okay, so resistance of 40 is higher than resistance of 100. Okay, and higher the resistance, it consumes more power in series combination. In series combination, higher the resistance, it consumes more power because current is constant. So power consumed is given by I square into R. Okay, so higher the resistance, more power is consumed. So you will get the brightest light from 40 watt because it has the highest resistance. So remember, in series combination, small value of power will give you more brightness. In parallel combination, high value of power will give you more brightness. Okay, so in parallel combination, smallest the power, more bright it will be. In parallel combination, highest the power, more bright it will be. Okay, remember this: series smallest, parallel highest. Okay, now combination of cells is also very, very important. Not Mohammad Ibrahim, not 100, because it is connected in series. If it is parallel, 100 would have been correct. In series, smallest is correct. Okay, smallest is the brightest, and in case of parallel, highest is the brightest. Okay, you can even calculate, assuming the power each individually, everyone is 220 volt, you can even calculate the power, but that will be a waste of time. In KCET, some questions you do not need to calculate everything, you can simply figure it out by understanding the concept. Okay, so higher resistance means higher power means lower resistance. Okay, that's why it has higher power. But in series combination, current remains same, so the consumed power is actually proportional to resistance. Okay, so higher resistance means higher power consumed. This rating has nothing to do with the power rating or power actually consumed by them. Okay, this rating is only an indication of their own internal resistance. So if you know the internal resistance, you can calculate which one will consume more power. Now, electric cells combination, there are two combination of cells. One is cells in series. In series combination, cells are connected one after another, similar to that of resistances. Okay, and the effective EMF is given by simply addition. Now if one of the cell is connected in the reverse order, then you have to subtract it. You have to subtract it. If one of the cell is connected in the reverse order, you have to subtract it. Okay, equivalent resistance is given by R12 plus R1 plus R2 plus R3 plus dot dot dot. Okay, now next, cells in parallel. Okay, cells in parallel is given by this tricky formula, but if you remember this formula, this is much easier than the formula given in your textbook. Okay, remember this: epsilon 1 by R1 plus epsilon 2 by R2 divided by 1 by R1 plus 1 by R2. This formula is much easier to remember and simplify than the formula that is given in your textbook. Okay, this is the shortcut, easier formula to calculate even difficult problems. Okay, and equivalent resistance is same as parallel combination, which is given by 1 by R1 plus 1 by R2 plus 1 by R3. Current in the circuit is given by I equals to epsilon equivalent by capital R plus R equivalent. This is the external resistance. This formula is common for both series and parallel combination. This formula is common for both series and parallel combination. Now, based on the cell combination of cells, we have seen a lot of questions in your KCET, especially in the year 2025. We see 2 questions. In the past also there are instances where few questions came based on this concept. Try to answer this question. In the following circuit, the terminal voltage across the cell is the terminal voltage. So if you see this kind of circuit, that means this is the EMF of the cell, and this is the internal resistance. Anything in series directly with the cell, that means this is the internal resistance. This is the external resistance, capital R, and terminal voltage means voltage between these 2 points. So how to do that? Okay, either you can use the formula directly, or what you can do, you can calculate the current in the circuit and then multiply the current with this. So that is also one way. But we will use the formula which states that V equals to epsilon minus I R equivalent. Okay, here I equivalent is only 1 R. So epsilon minus I into R. What is I? Formula for I is epsilon minus epsilon divided by capital R plus small r into small r. Okay, so this is the formula for I, and using this formula only we can calculate the terminal potential. So epsilon is 2 volt. So 2 minus 2 divided by R is 3.9 plus 0.1 into 0.1. Okay, so it will be 2 minus 2 by 4 into 0.1, or 2 minus 0.05, that is 1.95 volt. Okay, so 2 by 4 is half, and half means 0.5, and there is one more 0.1 multiplied, so 1.1 multiplied means it will be 0.05. So this kind of calculation tricks you have to master. If you want to solve KCET questions quickly, you have to master this kind of calculations very quickly. Even if I am solving it, I will start from this equation. I will even skip these 2 equations. I will directly start from this equation and directly answer the question that is option A, 1.95 volt. Next question. A wire of resistance capital R is connected across a cell of EMF epsilon and internal resistance small r. The current through the circuit is I. In time t, the work done by the battery to establish the current is. Okay, answer this question quickly. This is an easy question. Yes, Mohammad Ibrahim was correct. In the last case, it was option A. What about this question? A wire of resistance capital R is connected across a cell of EMF epsilon and internal resistance small r. So same question. Okay, circuit is same, epsilon R, but circuit is not given in the question, obviously. As you can see, the current through the circuit is I. In time t, the work done by the battery to establish a current. So if you remember the formula for power, formula for energy. Okay, formula for energy. What was the energy formula? Energy was vitamin. Okay, energy formula was vitamin. Okay, now when you are talking about vitamin, V is the voltage. Now when you are talking about a battery, instead of voltage, it will be simply the EMF of the cell. Okay, current is I, time taken is t. So this is the energy that is being spent by the battery, and whatever energy is being spent from work energy principle that you have studied in your PU1, Okay, the same energy has to be converted into work done, so that is equals to the work done. Energy and work are same, they are brothers, they are opposite sides of a coin, same coin. Okay, so from one side if you see energy, other side will be work. Okay, so the energy that you are spending is epsilon IT, so that means that should be the work done as well. That should be the work done as well. So for question 11, option D. Yes, Rashmi is correct. Muhammad Ibrahim is also correct. Prajwal is also correct. Everyone is correct. In fact, Kavya is also correct. So answer is epsilon IT. Don't be fool. Don't answer I square RT or E square T by R. It should be done by the battery. So energy done by the battery is epsilon IT. The useful work is this one, because remaining part is wasted in the internal resistance. So if they ask you useful energy, so this is the useful energy, but it does not necessarily mean that whatever is useful that is being done by the battery is doing more work, epsilon IT, okay, or EIT, which is the work done by the battery. Okay, so you write a question in the exam, part of that exam is correct, part is not correct. So that does not mean that you have done less work. You have done the full work, but useful, that is the marks that you are getting, is only for the correct portion, right? Now, so these were the KCET exam question. Now try something related to board. If the terminals of a cell are connected to an external resistance, then the potential difference across its terminal is more than EMF of the cell, less than EMF of the cell, equal to EMF of the cell, equal to the potential drop across its internal resistance. So again, so as you can see, as soon as we switched from KCET level to PU level, the question becomes easy. Okay, so if the terminals of a cell are connected to an external resistance, then the potential difference across its terminal is more than EMF of the cell, less than EMF of the cell, equal to EMF of the cell, equal to the potential drop across its internal resistance. Useful energy means, so suppose what should I say, suppose you in future you will earn money. Okay, suppose you are earning, suppose you went to a shop. I am giving a more general example. You went to a shop to purchase a biscuit packet. Okay, suppose the biscuit packet is 10 rupees. Okay, so you are spending 10 rupees to get that biscuit, but are you getting the biscuit which is equivalent to 10 rupees, or the biscuit the company spent 10 rupees on the biscuit to prepare it, to make it? Obviously no. Okay, if you are spending 10 rupees, okay, first of all 1.8%, 18% or 1.8 rupees is taken by government. Okay, this much is taken by the government as in the form of GST. Okay, now you might argue that, sir, now that GST price is reduced. Okay, so whatever GST is there, maybe for biscuit it is 5%, so that 0.5 rupees is being taken by the government. Okay, so this is the tax that you are paying. The company is spending on advertisement, on some transport, shipment, etc. So company is spending, say, rupees 2 per packet. Okay, rupees 2 per packet on advertisement, on transport, on packaging, on manufacturing equipment. So these 2 rupees is also you are not getting. So how much remaining part you are getting? You are getting only say this is 50 paisa only. Now 5% GST is there, so you are getting 50 paisa is paying, you are paying taxes. 2 rupees is being spent by the company on other things. So you are basically getting biscuits worth 7.5 rupees only. Okay, so when you are buying a biscuit of 10 rupees, this money is spent by you, but the useful amount that you are getting is only 7.5 rupees. Okay, so this is the useful work. Similarly, when a battery is doing work, okay, it has to do work against its internal resistance. So internal resistance you can consider is like the spending by the company itself to promote the brand. GST tax is not there, okay. So promote the brand, the battery has to have an internal resistance to safeguard itself, okay, so that the battery does not burn out. So that spend you have to accumulate, and remaining amount is basically the useful work that you are receiving. So you are switching on the light, okay, you are spending say 60 watt of light, but actually the spend on that 60 watt light is more than 60 watt. Okay, 60 watt the bulb is giving you back as a light in the form of light, but the bulb internally is consuming more than 60 watt of power. Okay, similarly a battery, if it is saying that I am 1.5 volt battery, it is not actually giving you 1.5 volt, it is giving you slightly less than 1.5 volt. Okay, so useful work means the work that you are getting from the battery, and the work done by the battery means the total work done by the batteries. Total work is this and useful work is this. Okay, clear? The easiest example, option D, option B, option B. So if the terminals of a cell are connected, terminals of a cell is connected across a resistance, that means there are some voltage drop across this cell. This is the portion that is being spent by the company itself. So you are always getting a voltage which is less than that of the less than the EMF of the cell. So you are always getting less than the EMF of the cell. So option B is correct, not option D. Correct? Rashmi, correct your answer. It is not a D. Next question. Okay, next question is not there. We will see few more, then we will solve some more questions. Okay, Kirchhoff's rule, this is the last topic, and Wheatstone Bridge, Kirchhoff's rules and Wheatstone Bridge are the last topic of the day. We will solve more questions obviously, but topic wise this is the last concept. Junction rule, KCL. At any junction, the sum of the current entering the junction is equal to the sum of currents leaving the junction. So this is called junction rule, and sometimes it is also called Kirchhoff's current law. So suppose junction means what? Junction means where more than two components meet. Suppose this is 1 point, this is 1 point, this is 1 point, and this is 1 point. So here at this point 4 resistances are meeting, so this point is called a junction. Okay, like a railway junction, Kempegowda junction. So where more than one line coming from Mysore, coming from other parts of the city, okay, so they all are meeting at that point. That's why this is called a junction, where more than one line meets each other. Okay, so this is the junction. Now if suppose I1 current is going in this direction, I2 current is going in this direction, I3 current is coming out, I4 current is also coming out, then the sum of the input current should always be sum of the output current as well. Sum of the input current should be equals to sum of the output current as well. Okay, this is the fundamental of Kirchhoff's junction rule, also called Kirchhoff's current law. This is a direct consequence of conservation of charges. Junction rule or current law is direct conservation of charges. Okay, loop rule or voltage law. Okay, this is the most important of them all. Now in PUC and KCET you may not get direct question except for this 2 points, but this has a lot of higher order application in PUC as well as in your KCET. Okay, so if you are able to solve those questions, that means you are at a very good shape. The algebraic sum of charges in potential, algebraic sum of changes in potential around any closed loop involving resistors and cells in the loop is 0. So here suppose you have a resistance, okay, and not one resistance but multiple resistances, and you also have a cell. Now Kirchhoff's law states that whatever current that is being passed in the circuit, if you go in a loop, then all the voltage drops, sum of all the voltage drop should be equals to 0. Now I personally like to modify a little bit. Okay, I like to add the voltage across the resistances. Now how to calculate voltage across a resistance? Voltage across a resistance is nothing. Suppose, let me complicate the circuit a little bit. Suppose this is R1, then we have say R2, and then we have one more resistance. Okay, so this is R1, R2, R3, and this is say voltage V. Okay, now suppose the current through this is I1, current through this is I2. Now when you are first, you have to apply, whenever you are solving a question, first step is to divide the currents using junction rule. So I1 through R1, I2 through R2, so total current should be I1 plus I2. Okay, total current should be I1 plus I2. Now when you are taking a loop means you have to move in a path without lifting your pen. You have to move in a closed path without lifting your pen. Okay, so this is an example of a closed loop. This is another example of another closed loop. Okay, so these two are different loop. Now whenever you are solving a question involving a loop, okay, I like to say that sum of all the voltage drops, that is equals to the voltage source. This is the easiest way to remember. Okay, sum of all the voltage drop should be equals to voltage. Now in some cases you will get current in the opposite direction, so in that case you have to subtract it. Here everything is getting added because we are moving in the same direction, so in that case it is summation or addition. In case some current is moving in the opposite direction, you have to take subtraction as well. Okay, we will see that through some example. One of the greatest application of Kirchhoff's law is Wheatstone Bridge. Okay, so Wheatstone Bridge basically have four arms, P, Q, R and S. Okay, these are the arms of a Wheatstone Bridge. So suppose I1 current is in this direction, I2 current is in this direction, I3 current, now I4 is slightly wrong, let me correct that. Okay. Okay, this is the direction of I4. Now if you can see everything like this, then this is called a Wheatstone Bridge. This structure is similar to that of a bridge. Okay, that's why it is called Wheatstone Bridge. Wheatstone is a name of a person. Okay, so the condition of balance, what is the balanced condition means? Balanced condition in a Wheatstone Bridge means this central galvanometer, this is a galvanometer. Okay, so if you are not seeing any deflection of the galvanometer, then we say that the Wheatstone Bridge is balanced. So in balanced condition, no current flows through the galvanometer. That means the galvanometer current is 0. Sir, is there any free mock test for KCET? Nataraj, yes, you can register for ABHYAS KCET test series. 4 tests are absolutely free. In the past we have given you 9 mock tests for free, but that was for our 100K celebration. I am not sure whether that is still available or not. That was there, but right now you can get 4 mock tests for free if you register for ABHYAS, and only through our app you will get those free tests. Okay, it will not come in your email as a attachment or downloadable content. You have to use our app or website to access those 4 free tests. Okay, so those tests are free, but you have to register yourself, and then you can use your login credential to get those 4 free tests. Okay, it will be only available via app or via website. Okay, it will not come to your inbox like we did in your in the past. Now the condition of balanced Wheatstone Bridge is P by Q equals to R by S. So P divided by Q equals to R divided by S. This is the condition of balanced Wheatstone Bridge. Okay, now two questions from KCET back to back. In the circuit shown, the end A is at potential V0 and end B is grounded. The electric current I indicated in the circuit is. So what is the current indicated in this circuit? So here if you see, there is a current mentioned in the circuit, I. So you have to calculate what this current I is. Okay, so circuit looks complicated, but how to solve such questions? Now if you go back to our previous part, this entire complicated Wheatstone Bridge can be redrawn into something like this. So this is the Wheatstone Bridge diagram. Now if you are wondering what is this, sir, so remember this is P, this is Q, this is R, this is S, and this one is galvanometer. Okay, so this circuit can be redrawn like this. So galvanometer, if you switch the circuit like this, then you will get a circuit diagram like this. So this circuit diagram is nothing but Wheatstone Bridge. Okay, many students get confused. So if you extend this, okay, you will get the idea that in fact you can say this is Q, this is R. According to this diagram, this is Q, this is R. Okay, so if you extend this diagram, so just you expand this. Okay, so this is the point where everything starts. So this is the point A. Okay, from here P, we have just redrawn it. Okay, this is P, this is R, in between we have G. Okay, and G is common for Q and S as well. So this is Q and this is S. So this circuit diagram is nothing but your Wheatstone Bridge, and this is a smart way to draw a Wheatstone Bridge. Okay, the many people do not able to draw this diagram, and for any competitive exam this diagram is very, very important. Right, now any circuit is given in this form. First of all, you have to understand this form is nothing but a Wheatstone Bridge. So this is a Wheatstone Bridge. Second thing, you have to check whether the Wheatstone Bridge is balanced or not. How to check whether the Wheatstone Bridge is balanced or not? So you have to see, this is R, this is R, this is R, this is also R. So definitely if all the resistance of a Wheatstone Bridge is same, then definitely it's a balanced Wheatstone Bridge. Now in this case everything is R, so problem becomes much easier. If some cases, suppose you see that this is R, this is 2R, okay, this is R, this is 2R, then also it's a balanced Wheatstone Bridge. Okay, R divided by 2R equals to R divided by 2R, that means it's a balanced Wheatstone Bridge. If this divided by this equals to this divided by this, then we say the Wheatstone Bridge is balanced. Okay, now in this particular case obviously all the resistances are same, so it becomes much more easier. In case of a Wheatstone Bridge, if all resistances are same, the equivalent resistance is also R. Okay, so this entire thing can be simplified to be resistance R. Okay, So how to do that? First of all, it's a balanced Wheatstone bridge. Balanced Wheatstone bridge means you need to delete this portion. So this portion does not play any part. So basically it's an open portion. So open portion means now if you see that this R and this R, they are in series. So R plus R is 2R. And again R and R are in series because this does not exist. So R and R in series. So this becomes 2R. And again in that parallel combination we have another 2R, R plus R. So 2R and 2R are in parallel. So 2R into 2R divided by 2R plus 2R, that is equals to R. So if, remember this will be helpful for you. If all the resistance in a Wheatstone bridge are same, then their equivalent resistance will also be the same value. Okay. So this one will be R, and if you see this circuit, everything is again 2R, so you can again eliminate this one. This is the galvanometer, so balanced condition means no current flows through this. That means this can be deleted. Okay, you can simply cut it and remove it. Okay, so this one will give you a resistance of 2R. Okay, now if you see that one side of the circuit is at a plus V voltage, other side is grounded. Grounded means 0 voltage. Okay, now R and 2R are in series. So R and 2R in series means the total resistance will be 3R. Total resistance will be 3R. And this one will be plus V0. Okay, so what is the current? What will be the current? Current will be very simple. V0 minus 0 divided by 3R. V by R, here one side is plus V0, other side is 0, so V0 minus 0 by 3R. So current will be V0 by 3R. Okay, it's an easy question, and previously Wheatstone bridge based questions are very common in KCET because there was one concept called meter bridge, which was an experiment that you used to perform in your laboratory. Now meter bridge is no longer part of the syllabus, neither in theory nor in practicals, so you cannot expect a meter bridge based question. But this circuit diagram, you remember, might be you see one more question based on the similar circuit. Now question number 14, very easy question. Nowadays this question is very common in your PUC exam as well. Kirchhoff's junction rule is a reflection of 13A, no 13A Mohammed Ibrahim, 13A is not correct. So this is R plus 2R, they are in series. So R plus 2R means it will be V0 by 3R, not V0 by R. Okay, be careful. You need to practice such questions again and again. Once more you have to practice it. Understand why I am deleting this resistance. This is nothing but the galvanometer of Wheatstone bridge. The Wheatstone bridge is in balanced condition. So if the Wheatstone bridge is in balanced condition, the central portion of the resistance goes away. So this is now in series. This one is again in series. These two are in parallel. Okay, so these two are in parallel. So series and parallel. That means what you get is the parallel combination formula. So parallel combination formula gives you R. Now one easier thing that you can remember, all the resistance same, that means the total resistance will also be same. Now that is only for this portion. There is one more portion on here. So this one is R, this one is 2R. So R plus 2R will give you C. Okay. Now 14, I think most of you answered correctly. Conservation of charges, junction rule or current rule, conservation of charges. Okay, Kavya, I can see Kavya, Mohammed Ibrahim, Dhanush, everyone answered 14C. This is the easiest question. Now answer this question. In the following network, potential at O. In the following network, potential at O. So you have to calculate the potential at O. You have to calculate the potential at O. How to do that? So if you see in the in this diagram, this point has a potential of 8 volt. Okay, this is a KCET ready problem, not a KCET previous year question, but this type of question is very common. Suppose the potential here is VO. Potential here is VO. So this one is 8 volt, this one is VO, this one is 4 volt, this one is 2 volt. So voltage is reducing. Voltage reducing means current generally should flow in this direction. So suppose this current is I. Okay, this current is I1, this current is I2. Okay, then from Kirchhoff's current law or Kirchhoff's junction rule, we can say I equals to I1 plus I2. It must be, right? So now if you can calculate I1, I2 and add them, we can calculate VO. Now consider this portion. This is a simple resistance. Through this simple resistance, this point is at 8 volt, this point is at V0 volt. So what is the current that is passing through this? So what is Ohm's law? Voltage difference divided by resistance. So current I is nothing but voltage difference, that is 8 minus VO divided by the resistance, which is 2. So this is I current. What about I1? Now current is flowing from O towards B, right? So this point is now at higher voltage, this one is at lower voltage. So I1 will be equals to V0 minus 4 divided by 4. Okay, what about I2? So voltage difference by resistance, that is current. Okay, that is the Ohm's law. So voltage difference, again the direction is always higher voltage to lower voltage. So V0 must be again higher, 2 must be lower, divided by 2. Now we have calculated 3 currents. Now we will apply Kirchhoff's current law to calculate. So I equals to I1 plus I2, or 8 minus V0 by 2 equals to V0 minus 4 by 4 plus V0 minus 2 by 2. So if you see that common LCM of 2 and 4 is 4. So if you multiply each and every term with 4, we can eliminate the division part. So this will be cancel, so we will get 2. So 2 into 8 minus V0 equals to V0 minus 4 plus 2 into V0 minus 2. So very basic simplification. 16 minus 2 V0 equals to V0 minus 4 plus 2 V0 minus 4. So we get 3 V0 minus 8. Okay, so now we have to rearrange. So 16 plus 8 equals to 3 V0 plus 2 V0, or 5 V0 equals to 24. 5 V0 equals to 24. So V0 should be equals to 24 by 5, that is 4.8 volt. Okay, so remember how to tackle questions that you may feel little difficult. Okay, I have tried to simplify the question as much as possible. Okay, those who are able to solve the question faster, definitely they will be able to answer this question much earlier. Okay, I have elaborately explained the calculation. Some of you may struggle with the calculation steps, so this is how you should solve. If I am solving it for myself, I might directly start from this equation. Okay, now let's solve one numerical. I will not solve this numerical, I will solve this numerical. Find the voltage difference across the 10 ohm resistance. So we have to calculate the voltage difference across 10 ohm resistance. This is a PUC level numerical question. Okay, find the voltage across 10 ohm resistance. So here is the circuit. So if you see the circuit, in this circuit the currents are already given, I1, I2, I3. Now what is the voltage drop across 10 ohm resistance? Voltage drop across 10 ohm resistance is basically the current I3 into 10. current I3 into 10. So if you can somehow calculate this current I3, you will also be able to find the voltage drop across this resistance. Okay, so as you can see there, here we have 6 ohm, 4 ohm. The battery, the cell itself also have an internal resistance. So internal resistance generally is in series with the cell. So that is the internal resistance. Okay, similarly this one will also have an internal resistance. This is also internal resistance. Okay, now there is a shortcut way, there is a long way, there is a shortcut way. So if you see at this point B, I1 is current is going in this way, I2 current is also going in this way. So from here we can say that I1 plus I2 equals to I3. So whenever you are solving a question, circuit theory based question, yes, option D, yes. So whenever you are solving a circuit theory based question, first step is to apply Kirchhoff's current law or Kirchhoff's junction rule, okay, and simplify the current. Once you simplify the current, then you have to apply Kirchhoff's voltage law. Okay, now in this particular case we are trying to find I3. Now because I1 plus I2 equals to I3, you can do one thing. You can calculate I1, you can calculate I2 and then add them to calculate I3, or you can directly calculate I3 by at least simplifying one of them, that is I2 equals to I3 minus I1. You can simplify this and you will get two equations. You have to solve them to get I3. If you can do that, and remember this kind of questions generally do not give you any pretty answer. Answer can be little tricky. Okay, answers are not very pretty, not very good looking, but you might face such questions in your board exam, so be prepared. Okay, now so here we have 4 volt. This is the direction of current, so we will take 2 loops. First loop is this one. First loop is this one, okay, and we will always try to move in the direction of the current. We will always try to move in the direction of current. Okay, so battery is sending a current I1, so the current that will back through the battery will also be I1. That is also conservation of charge. So that means current through this 4 ohm is also I1. Okay, so I1 current is going in this way. The I1 current is passed through 2 ohm, I1 current will pass through 6 ohm, I1 current will pass through this 4 ohm as well. Only in between, through this resistance 10 ohm, current is I3. Similarly, for this battery, if we go in this direction, the direction of the current, okay, we will see that the current I2 is exiting the battery, so the same current should come back to the battery as well. So no matter what, if a current exiting a battery, the same current has to come back to the battery. That means I2 current will also pass through this resistance as well. Now we will apply Kirchhoff's voltage law. Now next step is to apply Kirchhoff's voltage law. First step is to apply Kirchhoff's current law to simplify the currents, find the interrelation between the currents. Second step is to apply Kirchhoff's voltage law to find the relationship between currents and the voltage of the battery. So when you are applying voltage law, as I mentioned, if you are going in the direction of the current that is being sent by the battery, you can add all the voltages and you can say that is equals to the battery voltage. So first we will start with 2 ohm. So 2 ohm is the internal resistance, and through this 2 ohm current is being passed is I1. So what is the voltage drop? Voltage drop is 2I1. Next 2 ohm is done. Next is 6 ohm. So what is the current through this 6 ohm? Current through this 6 ohm is also I1. So it will be 6I1. Next we are considering this resistance. Through this the current is I3, so voltage drop is current into voltage. Voltage drop is current into voltage. Current into resistance. V is equal to IR. Okay, for individual resistances we have to consider them individually. That's it. Next is this 4 ohm. Through this current is I1, so for this is also 4I1, and that should be equals to the voltage of the battery. So we have received one equation. We have received one equation. So it will be 2 plus 6 is 8, 8 plus 4 is 12. So 12I1 plus 10I3 equals to 4. Or we can even divide it by 2. We get 6I1 plus 5I3 equals to 2. This is our equation number 1. This is our equation number 1. Next step, this is from the loop on our left hand side. So this is our loop 1. Next we will apply the same thing in loop 2. So when you are applying in loop 2, so here we have 2 volt as source, internal resistance as 1 ohm. So we have 1 ohm into I2. Okay, 1 into I2 is obviously I2 plus 6 into I2 plus 10 into I3. Again we are going in the same direction, that means everything will be added. If somewhere you face a current which is in opposite direction, there could be a negative sign. Plus here it is 4 into I2. Do not worry about sign. Okay, if the direction is opposite, the final result will show it. So don't worry about it. Final result can be positive or negative. So don't worry about the sign. So now add I2 plus 6 plus, that is 7. 7 plus 4 is 11. So 11 I2 plus 10 I3 equals to 2. Now, so here you can eliminate I3, find the relation, or complicate things, or you can use this equation and find the relationship between I1 and I3. So we will use the second one, that is we will not try to complicate it. 11 into I3 minus I1 plus 10 I3 equals to 2. Okay, now simplify this. We get 11 I3. This is a PU board exam. Obviously, it will take some time. PU board level question. Okay, PU board generally gives you a question which requires a slightly longer. 10 I3 equals to 2. Okay, now simplify. We get minus 11 I1 plus 21 I3 equals to 2. Okay, so this is our equation number 2. Now you have to simplify this. How you can simplify this? Basically method of elimination. Multiply equation number 1 with 11 and equation number 2 with 6 and add them. So if you multiply 11 to this, you will get 66 I1 plus 55 I3 equals to 22, and here you will get minus 66 I1 plus 21 into 6, 126. 126 I3 equals to 12. So if you add them, this one cancels and you get 181 I3 equals to 34, or I3 equals to 34 by 181. Okay, so this is the value of I3. So what is the voltage drop? This is not our answer. Answer is voltage drop across the 10 ohm resistance. The voltage drop across this is 10 I3, that is 340 divided by 181. Now you are allowed to use calculator in your board exam. Simple calculator, you can calculate and simplify it. Okay, clear? Now the formula sheet for this chapter is also provided along with this lecture. So if you want to download the formula sheet and along with all the lecture question, then definitely you have to join the WhatsApp channel. The PDF will be shared in our WhatsApp channel through specific link, the drive link. Drive link is already shared once. Same drive link will be accessible to you. If you have the drive link saved, you will get this lecture note once this lecture is over. Okay, drift velocity is given by this, current is given by this, current density, mobility. So all important formulas that you require to remember from this chapter is provided in this single formula sheet. Okay, and that is very, very handy for you. I am not doing anything new, everything is already discussed in this lecture. Okay, so this is the formula sheet that you need, and also you will get 5 homework problem that you can solve and let me know the answers in the comment section. 1, 2, 3, 4, 5. Okay, you can pause the video if you want right now. If you don't want to do the hassle of downloading the PDF, answering it, you can answer it right now. You can pause the video if you wish and solve it and mention the answer in the comment section below. So this is question number 1, this is question number 2. Okay, this is question number 3. Okay, this is question number 4. I am not giving you time right now. You can solve it once the lecture is over, at your own pace, at your own time, and only mention the answer in the comment. Okay, mention the answer in the comment. Once this live video is over, the main comment section will be open, and then you can comment on the main comment section. Okay, please wait for some time. Once the live is over, the live closes from our end, then you will get the option to mention in the comment below, main comment. Okay, so you see that the video comment, so you can mention there. This is question number 5. Okay, pause the video if you wish, or you can download the PDF available exclusively in our WhatsApp channel. You can join our WhatsApp channel through the link given again in the description section of this video, and the description section of all our videos have our WhatsApp channel. Most of you are part of it, some of you may not, so don't forget to join the WhatsApp channel. Again, if you are watching for first time or you have recently started watching, don't forget to subscribe to our channel. Right, so this is the end of today's lecture. I'll be back with more live sessions very soon. Also, our master stroke live session is starting from this Saturday. I am not there in Saturday, but I'll be there on Monday. So don't forget to join my live session if you want to do well in your PUC as well as in your KCET exam. Right, all the best for your future. I'll be back. Till then, bye.